classroom teaching. Students, in last period we have seen, in last video we have seen how the image is formed by convex and concave lens. We know that the image formed by a convex lens, it is maximum time it is real and we can take it on screen. We see that. But what is sign convention and why it is required, why it is needed, that we are going to study today. This sign convention is given by Cartesian. It is called as Cartesian sign convention, and according to this sign convention we can use the proper signs for the object distance, image distance, height and everything. First, keep in mind that the object distance, it is always given, we use the letter U for that, small u. Image distance we measure and we give the letter V to the image distance. This is object distance. This is image distance. Then height of an object, it is taken as h1. Height of the image is taken as h2. And the focal length, it is always given by small f. Now, which signs we have to use for that? For that, these Cartesian sign conventions are given. Here you can see the diagram for convex lens and for concave lens. The Cartesian sign conventions are similar for both the lenses. We are comparing here. Okay. So, according to the Cartesian sign convention, it is nothing but coordinate system that we learn in mathematics. Coordinate system, x-axis and y-axis. So this is x-axis, this is y-axis. Here it is x-axis, it is y-axis. So it is similar to the coordinate system. And the origin of the coordinate system, it is nothing but the optical center O of the lens. Here also we take optical center O. This x-axis, it is nothing but which is that axis passing through O, it is principal axis. So x-axis we take for reference as a principal axis here. So what is Cartesian sign convention? It is nothing but whenever we draw the ray diagrams, we take object here. Suppose always the object is taken to the left of the lens. Actually, we learn it in 9th standard also. We see the Cartesian sign conventions for mirror, concave and convex mirror. It is similar here. So, first condition, object is always taken to the left of the lens. Object is always upright, that means it is above the principal axis, and therefore all the distances measured parallel to the principal axis and to the left of the lens, they are always taken as negative. The distances measured to the left of the lens, they are always taken as negative. The distances measured to the right of the lens and parallel to the principal axis, they are measured as positive here. One more thing, all the distances perpendicular to the principal axis and above the principal axis, they are always taken as positive, whereas all the distances measured perpendicular to the principal axis and below the principal axis, they are measured as negative here. Just keep it in mind. So tell me, if I tell you the object is placed at a distance of 10 centimeters from the lens. Suppose I have given the example, if the object is placed 10 centimeters from the lens, So, though it is given 10, the u must be taken as minus 10 centimeter. Why? Because it is not given every time, but we must know the object is always placed to the left of the lens, and therefore all the distances to the left they are negative. So u must be, instead of 10, it must be minus 10. So we must use these laws or these Cartesian conventions, sign conventions, whenever we are solving the problems. Whenever we solve numericals, at that time it is not given every time, but we must remember this thing. Second thing, we know the focal length of a convex lens, it is a converging lens, and therefore here it is the focal length for a convex lens. So the focal length of a convex lens f is always positive. I am writing here for convex lens, u is always negative, f is always positive, height h1 is always positive because the object is always taken upright or above the principal axis. Let us think what is about concave lens. Suppose the object is placed here. So h1 it is always positive, height is always positive, height of object. What is u? U is always negative for both the lenses because the object is always placed to the left. Okay, so what about focal length f? Here we take the focal length as positive, always positive for convex lens, and here the focal length is always negative because this is a diverging lens. Its focus is virtual. Here the focus is there. So the distance to the left, it is always negative. So the focal length of a lens is negative. Concave lens is negative. And actually, whenever you solve the numericals, it is not given in it. Only they give the focus or the focal length of a concave lens is, suppose it is 20 centimeters is given. So, though it is given it is 20 centimeter, it should be taken as minus 20 centimeters because the lens is concave, it is given there. So, as object distance, height of object and focal length, if the image of this, let us see where the image is formed. If the object is placed between f1 and 2f1, image is formed beyond 2f2. Here suppose the image is formed. So the height of the image is, definitely it is negative. So h2, if we think, h2, it is always negative if the object is upside down or if the object is inverted below the principal axis. So h2 is negative here. What about v? V is image distance. Image distance, all the distances we measure from the lens. So image distance, it is to the right of the lens and therefore it is positive here. So for convex lens, if we think for convex lens, the image distance v and height of image h2. When the h2 is positive, it is the only one condition whenever the object is placed between f1 and o. Whenever the v is negative in convex lens, only one condition whenever the object is placed between f1 and o, because if the object is placed here, the image is formed on the same side. So just keep in mind, take the optical center O as the origin of the coordinate system and Then keep in mind all the distances to the left of the lens, they are taken as negative. All the distances to the right of the lens, they are taken as positive. And all the distances perpendicular to the principal axis and above the principal axis, they should be positive. All the distances below the principal axis and perpendicular to the principal axis, they are taken to be negative. So this is nothing but Cartesian sign conventions. Focal length of a convex lens is always positive and the focal length of a concave lens is always negative. So this is about Cartesian sign conventions for lenses. Now let us see what is lens formula. Lens formula, it gives the relation between object distance u, image distance v and focal length of the lens. So it gives the relation between, so at 1 by v minus 1 upon u is equal to 1 upon f. It is lens formula and it is true for both the lenses, concave or convex, or all types of lenses. But the condition is we should use proper sign conventions. We should use proper sign conventions for that. What is the meaning of proper sign conventions? If the convex lens is there, f should be taken as positive. If concave lens is there, f should be taken as negative. U is always negative, that is object distance, and V is according to the image where it is formed. So this is lens formula, 1 by V minus 1 upon U is equal to 1 upon F. Then these are very small articles. Second is magnification. So these are terms only, not articles. Magnification. We know what is magnification. We have suppose magnifying lens. What is the purpose of that lens? We make the object bigger. So magnification means to make it bigger. Is it? No. It may become smaller or may become bigger. So magnification, we can give it magnification of a lens can be given by height of image divided by height of object. Magnification capital M is equal to height of image divided by height of object. Here also we should use proper sign conventions. So this M, it is given by H2 upon H1. Here in this case H1 is always positive because it is height of object and we take object above the principal axis. Okay, but depending upon the sign of H2, magnification, it may be positive or negative. So we should use proper sign conventions. Again, I am telling it again and again. We should use proper sign conventions. If the height of the object, that means if the image is inverted, then H2 must be negative. If the image is upright, then H2 must be positive in that case. And according to that, magnification is also positive or negative. So depending on that, magnification, it may be positive or magnification may be negative. So this magnification, it is given in terms of distance of object and image also. Here height of image divided by height of object. Similarly, instead of height, if we take distance distance of image divided by distance of object. So distance of image we take as V from the lens divided by distance of object is U. So it can be given by V upon U. Here also we must consider proper sign conventions. What is the meaning of that? U must be negative always, because the object is always kept to the left of the lens. So U must be negative always. And if we get real image, then V is positive, because real images they are formed to the right. Okay? And if the image is virtual, that means on the same side of the lens, then V must be negative. So we should use proper sign conventions again. So by combining this formula, or this is the combined formula, magnification M is equal to H2 upon H1 or is equal to V upon U. If any two things, either distance of the object and distance of image is given, then also we can calculate magnification here. Or height of object and height of image is given, then also we can calculate magnification M. Okay. Then the next is power of lens. What is meant by power? I will give example here. Suppose these are two lenses, both are convex lenses. If the light rays which are falling parallel to the principal axis, we know they pass through focus because of the divergence. Here the light rays they converge here. So due to this convergence, we get all the light rays focus here. So it is focus. What is focal length? The distance between O and F, it is focal length. Okay. Here also, light rays parallel to the principal axis, after refraction, they passes through focus. So they passes through focus here. So here it is focus F. The focal length is distance between optical center O and focus. So this is focal length here. Here it is focal length. So which lens has more power? Which power? Converging power. Definitely we can say the light rays they get more converged here. So converging power of this lens, suppose this is A, converging power of A is more than converging power of F, this B. How? Because the light rays they get more converged. That means the angle of convergence is more here in this case, and therefore it has more converging power. So the power of the lens it is given. It is always given in terms of focal length. More the focal length, less the converging power, and therefore it is inversely proportional. And therefore we can get here power of lens is equal to 1 upon F. It is the reciprocal of focal length. But the condition F must be in meter. So power, the unit of power is diopter. So 1 diopter is equal to 1 upon 1 meter. 1 meter it is the focal length. So power is given by 1 upon F, 1 upon focal length, and the focal length must be in meters. It is given in exam that if the focal length of a convex lens is 50 centimeters, then calculate the power of that lens. It is given in centimeters, we require it in meters. So we should convert it first into meter, and then by using this formula we can easily find out the power of lens. If we take combination of lenses. Suppose I took these two lenses in contact with each other. What is the power of this combination of lenses? So the power of this combination, it is nothing but P is equal to P1 plus P2, where P1 is power of this first lens A and P2 is power of the second lens B. So the combined power of the lens, this is equal to P1 plus P2, or we can use this formula also. So 1 upon F of combination is equal to 1 upon F A plus 1 upon F B, where F A is the focal length of first lens A and F B is the focal length of second lens, that is B. So these are few terms which are related with the convex lens or concave lens, that means biconvex and biconcave lens, like magnification, lens formula, and always 100% at least one numerical is asked on this related with these formulas or related with these articles, these concepts. So it is very easy part of this chapter, of this lesson. So with this we will stop here, and in next video we will see about human eye. Okay. So try to practice the numericals which are given in the book and try to solve them. If there is any problem related to it, then give message to me on my personal WhatsApp number, or you can chat me on this channel also. Thank you very much.